Okay, today we're doing 2.4a for pre-calculus, which is factoring. So we're going to start by talking about factoring by grouping. You guys have done this before. Factoring by grouping is when we have four terms. So that would be where we have something like x squared plus 2x plus 3x minus 9. Okay, so we're going to put our parentheses around our first two terms, put our parentheses around our second two terms, take what we can out of here, so an x, and we're left with x plus 2. And take what we can out of here. And let's see, I got to change these numbers. Hold on. These numbers have to match. And I don't know what I did with my other example here. We'll make that a negative 3x, I don't know, minus 6. All right, so here we can pull out a negative 3 and we get an x plus 2. The reason I did that is because when you're factor by grouping, that has to match. Okay, and these two have to match. So now I've done factor by grouping. Okay, so when you're factor by grouping, that's what it's going to look like. The two factors in here are always going to match. Otherwise, you've done something wrong. Difference of squares. Okay, this only works when there is a subtraction sign between two perfect squares. Okay, so when that's the case, you get a plus b times a minus b. You need to memorize this. Okay, so here, 25, the square root of 25 is 5. Okay, so this is my a squared term. So I'm looking for my a term. So the square root of 25 is 5, and the square root of x squared is x. So my b squared is 36. I don't care about that minus sign. I just care that it is a minus sign. So the square root of 36 is 6. So now I know it's 5x minus 6 times 5x plus 6. And it doesn't matter what order these go in. You could write 5x plus 6 times 5x minus 6. Doesn't matter. Perfect square trinomials. Okay, so I don't memorize this formula. You can factor it just normal factoring rules, which we're going to go over again in just a minute. But if you happen to know this pattern, then you can see it. And how you would find the pattern is I would take this b and I would say, well, that's b divided by 2. So negative 12 divided by 2 equals negative 6. And if I square that number, I should get that last term. Okay, so if that's the case, then you can easily say, oh, well, then this is x minus 6 squared. Whatever's there, okay, your b divided by 2 is always what goes there. Okay, so that's just something that you can do if you happen to see the pattern. But once again, I don't expect you guys to have to memorize this. You can factor this just like the normal rules that we're about to talk about also. It's just a shortcut. Okay, so the last part is actually factoring trinomials. So there's 9 steps here. I'm not going to talk through them all right now. We're actually going to work a problem and we'll talk through them while we work the problem. Okay, so step 1 is look for greatest common factor. So 7x squared, negative 9x, and 2. Okay, they don't all have something in common, so I don't need to pull something out. My next step would be to multiply my a times c. So that's going to be this term times this term, including the sign. So 7x squared times 2 is 14x squared. Okay, now my factor list, that's my factors of a times c. So I could get 1x times 14x, negative 1x times negative 14x. Remember, there will always be 2 sets of the same number because they'll have positives and negatives, or if this was a negative 14, this one could be negative, or this one could be negative. Okay, so you'll have different combinations and you got to try them all. So our other option here is 2x and 7x, or negative 2x and negative 7x. And notice if you didn't do the negatives, you would miss that right there. So what we're looking for is we're looking for the pair that when we add them together, so negative 2x plus negative 7x equals negative 9x. When we add them together, they equal that middle term. So now what we're going to do is we're going to change the way this function looks. So we're going to write 7x squared. We're just rewriting it. So 7x squared minus 9x. But instead of this minus 9x, I'm replacing it with this. You can either put them in this order or you can change the order. The order does not matter. I'm just going to put my minus 7x first because then I'm going to be able to pull something out of here. It doesn't matter if you can't. If you do the negative 2x first, that works just fine. Okay. So now I'm going to do my factor by grouping method. Okay. So 7x squared minus 7x, I can take a 7x out of both of those, and I'm left with x minus 1. Negative 2x plus 2, I can take a negative 2 out, and I'm left with x minus 1. Now remember on the second one, you always have to take at least a positive 1 out. Okay, if you take a 1 out, that's fine, but you always have to have at least the number 1 right here. Okay, otherwise you don't get a binomial, and you have to get 2 binomials. Okay, so remember binomial has 2 terms in it. Okay, and then x minus 1. So my answer here is 7x minus 2 times x minus 1. Remember in the beginning when I said we would look for greatest common factor? Well, if these all had something in common, like say they all had a 3 in common that I pulled out at the very beginning before I did all of this stuff here, then that number would go right here in front. Okay, you wouldn't just drop it. It would have to be in your answer. Okay, you just wouldn't have to use it in this. And we're going to have some examples here in a few minutes where we actually do that. So sum of cube and difference of cubes, you need to memorize these formulas also. Okay, pretty similar to the difference of squares, except whereas we have, you know, an a cubed and a b cubed, and we have to find an a and a b. Okay, but then the formulas are a little bit different. So make sure that you write these down and memorize them. So the first one says factor this. So this is my a cubed. And this is my b cubed. I need to find my a and my b. So the cube root of 8, in other words, a number times itself, it equals 8 is 2. Okay, and the cubed root of x cubed is x. Cube root of 27 is 3. Y. If you're unsure what these are going to be, just start. So 1 times 1 times 1 is 1. Nope, that's not 8. 2 times 2 times 2. 2 times 2 is 4 times 2. Oh, that's 8. Okay, 3 times 3 is 9 times 3 is 27. Okay, so just start off that way. So now I know that this was a plus. Okay, so I'm going to use this formula here. So it's going to be 2x plus 3y. Okay, and then I'm going to have 2x squared, which the squared goes on the outside, so I have to square that too. So 4x squared minus, my sign is always different from this one. 2 times 3, so 6xy. And then this sign is always a plus, 9y squared. Difference of cubes, exact same thing. So this is my a cubed. So my a would be 4x. This is my b cubed. So my b would be 5. So it's a minus here. So I'm going to use this formula here. So this is what we started with. So this is the formula I have to plug in. Okay. So that's going to be 4x minus 5 times 4x squared, which is 16x squared, plus the sign is always different from this one, a times b, which is 20x, and then plus, the sign's always a plus, 5 squared, which is 25. And we're done with that one. And you guys need to memorize those formulas and put them on note cards and study them. Factoring is so important. If you can't factor, you're going to struggle in this class. Okay, and I told people that in Algebra 2, and I'm telling you guys that again. Okay, the zero product property. The zero product property says that if a times b equals 0, then either a or b or both must be 0. So if I have a 2 times an x and it equals 0, then I know that x has to be 0. So it's the same thing if I'm multiplying 2 polynomials. So if I have an x minus 2 times an x plus 3 and it equals 0, then either this whole piece has to equal 0 or this whole piece has to equal 0. Okay? So we're going to solve a polynomial using that concept. So the first thing we're going to do is set the equation equal to 0. Okay? And we'll do that by either changing the f of x to 0 Or if there's a number on the equal side, then we'll add or subtract that to get 0. Then we'll factor, set each factor, so each of these are a factor, equal to 0, and solve. Okay, so let's take a look at this first one. So the first thing I'm going to do here, I'm going to pull out a -6 because they have that in common. So I'm going to have an x squared minus 3x plus 2. So now I'm going to ignore this -6 for a minute. It is going to be in my answer down here. Okay, but I'm just going to ignore it for a minute. So I'm going to multiply my a times c. So I'm doing my factoring just like I did up here. So that's going to be 2x squared, and I can multiply 1x times 2x, or -1x times -2x, and -1x times -2x is the pair that gives me that. So then I'm going to say x squared minus 1x minus 2x plus 2. Okay. I can take an x out of here, and I'm left with x minus 1. I can take a -2 out, and I'm left with x minus 1. So my factors here are x minus 2, so that's a factor, and those are my other factor. I also have this -6 as a factor. So now I'm going to take all of my factors and set them equal to 0. So -6 equals 0. X minus 2 equals 0. X minus 1 equals 0. Well, -6 is never going to equal 0, so I don't need to worry about that one. Okay, but we have to remember to set that factor equal to 0 also, because sometimes this might be an x or a 3x. Okay, and so x might actually be 0. So here I'm just going to solve for x for both of these, and I get x equals 2 or x equals 1. So if x equals either one of these values, okay, then this whole thing will equal 0. Okay, and what we're talking about here when we say solving, we're talking about a solution. Okay, we're talking about the x-intercepts. So where does this parabola, this graph, we're going to talk about parabolas in the shape a little bit later, where does this cross the x-axis? So let's take a look at this next one. So this next one, first thing, greatest common factor, they all have an x in common. Okay, so now I'm left with 6x squared plus 5x minus 4. Okay. So this x, I don't need to worry about right now, but it does have to go in my answer. So I'm going to bring it down so I don't forget about it. And now I'm going to go on ahead and multiply my a times c, and I get -24x squared. So that could be a 1 times 24, or that one could be negative, or that. Let's see, 2 times -12, or -2 times +12, or -3 times 8. Or +3 times -8, and I'm going to go on ahead and stop there because I see I've hit my pair. Okay, so now I'm going to have 6x squared minus 3x plus 8x minus 4. Okay. Out of this one, I can take a 3x, and I'm going to be left with x minus 1. Out of this one, I can take a 4, and I'm going to be left with 2x minus 1. I'm be left with 2x minus 1 here. Okay, so notice I immediately went back and said, ooh, this one's going to come out with a 2 and that one didn't. But it really did, because 6 divided by 3 is 2. Okay, I knew those didn't match. I knew there was a problem. Okay, so now I'm at 3x plus 4, and this one is 2x minus 1. So now I have to take all of my factors, x equals 0, and set them each equal to 0. So 3x plus 4 equals 0, and 2x minus 1 equals 0. So now I'm going to solve. So I get x equals 0. Okay, that's that one. I don't have to do anything to it. Subtract 4, and then divide by 3, and I get -4/3. Here, add 1, and divide by 2, and I get 1/2. So x can be any of these 3 values, and make this whole thing equal to 0. Oh, this whole thing equal to 0. Now, one thing I want to point out, there were 2 solutions here, and there's a 2 there. That is called the fundamental theorem of algebra. It says that whatever the degree of the polynomial is, so the highest exponent there, that is how many solutions there will be. So here there were 3 was the highest exponent. So there has to be 3 solutions. We will get into imaginary numbers a little bit later on. So if you don't always see that many of them, then there could be 2 of like this one, or there could be some imaginary ones. Okay, so we're going to talk about both of those a little bit later. Okay. So more of 2.4a, so finding zeros using a calculator. So make sure that you can do this. So in your calculator, you would go to y equals, and we're going to go ahead and type in x squared minus 5x plus 6. And we're going to graph it. Okay, so we want to make sure that we can see where it crosses the axis here. But you can see it's kind of far away, and it looks like it might cross twice, but I'm not sure. We know by this that it does cross twice. So what I'm going to do is I'm going to zoom. Okay, so I just hit my zoom key right here, and then I'm going to zoom in. But before I hit enter, I'm going to scroll. You can see this little bitty arrow here. Okay, I'm going to scroll it over so that it is kind of in the middle so that I can see what's happening right there. Okay, and now you can see it crosses my x-axis. So you have a couple of options. You could go to your table, okay, and you could see where y equals 0. So that's at x equals 2 and x equals 3. Okay. But that's not always going to work. So the other option is to hit second, trace, which will give you your calculate, and you're going to hit this 0. Okay. And then from there, you're going to have to scroll a little bit to the left of where you can see it crosses and hit enter. And then you're going to scroll a little bit to the right of where you can see it touches and hit enter. So that's saying, hey, do you want me to find a 0 between these 2 arrows? Yes, I do. So you hit enter again, and then it tells you your 0. And you have to do that for both of them. Okay? Like I said, sometimes it'll work and sometimes it won't. So sometimes the table will work, sometimes the table won't. This method always works. Okay. All right. So make sure that you know how to do that. You can check your work by doing this, but we're going to want to see all of the work worked out on these. Okay, so another way to solve would be the square root principle. So to solve a quadratic in the form ax squared plus c, so it's just missing that middle term, that x squared term, is just to solve both sides. Okay, so the important thing is consider the positive and negative square roots when you do this. So here, we're just going to solve for x. So we got to get the x squared by itself. So I'm going to add 12 to both sides. So I get x squared equals positive 12. Then I'm going to take the square root of both sides. So that gives me x equals plus or minus the square root of 12. But I never leave it like that. I want to simplify it. So 12, the square root of 12 breaks down to the square root of 3 times the square root of 4. Okay, so here you could either say, oh, well, the square root of 4 is 2. So you can go on ahead and write that that's, I forgot to bring my plus or minus. So plus or minus 2 square roots of 3. Okay, or if you prefer just doing the Christmas tree method and saying, oh, there's a pair, I pull a pair out, okay, and that's left over. So my final answer would be x equals plus or minus 2 square roots of 3. We have to put it in simplest form, never decimal form, but we always want it in simplest form. Okay, so this one right here, first thing I got to do, I have to get this whole piece by itself. So I'm going to add 4 to both sides. And I get 3x squared equals 72. Okay, I got to get the x squared by itself. So I'm going to divide by 3 on both sides. And I get 24. And then I'm going to take the square root of both sides. So x equals plus or minus, see, 24 is going to break down to, let's see, we can do 2 and 12. 12 breaks down to 3 and 4. 4 breaks down to 2 and 2. So there's a pair of 2's. And then this 3 and this 2 are going to have to stay under. So the pair of 2's comes out as a 2. Okay. And then we're left with a 3 times 2 underneath. Okay, so a 6. And that's my answer. Okay, this one right here is a little bit different. Hey, remember that I can't do anything inside the parentheses until I get rid of whatever's outside the parentheses. So I'm going to have to square root both sides first. So I get x minus 4 equals the square root of 25, which is 5. But don't forget that plus and minus. So now x minus 4 equals positive 5, or x minus 4 equals negative 5. And now I just add like normal. So x equals 9, or x equals negative 1. So those are my two answers now. Okay, we're almost done here. This is kind of a long section, but it's a lot of review. Okay, so the next one is completing the square to solve the quadratic. Okay, so the first thing we're going to do is move the constant to the other side. So we're going to add 27 to both sides. So now we get x squared plus 6x equals 27. The next thing we're going to do is we're going to add a blank to both sides of the equation. And really, we're going to put a plus a blank on both sides. Okay. To determine what goes in here, we're going to take this b term here, okay, the x term, and we're going to divide it by 2. So remember earlier when we did the perfect square trinomials? Well, that's what we're creating here. We are creating a perfect square trinomial. So 6 divided by 2 is 3, squared is 9, and that's what goes right there. So now this one becomes x plus 3 squared equals, and then 27 plus 9 is 36. Now we can solve it just like we did these previous problems. So we're going to square root both sides. Let's see, I'm running out of room. So x plus 3 equals plus or minus 6. Okay, so x plus 3 equals 6, and x plus 3 equals negative 6. So subtract 3 from both sides, and we get x equals negative 9 or 3. Okay, so if we plug either one of those values in here, it will give us 0. Let's take a look at this one. So on this one, the constant is already on the other side of the equal sign. So all we're going to do here is add our blanks. So x squared minus 8x plus blank equals negative 7 plus blank. Okay, we're going to take this negative 8, divide it by 2, and square that. So we get 16. So now we are going to, let's see, it's going to be x minus 4 squared, because that is always what goes here. Okay, or you can factor this like normal if you need to. Equals negative 7 plus 16 is 9. So now we're going to take the square root of both sides, and we get x minus 4 equals plus or minus 3, which is x minus 4 equals positive 3, and x minus 4 equals negative 3. Add 4 to both sides, and we get x equals 7 or 1. You can check your work, okay, this way. Okay, we're still finding the zeros. We're finding x. Okay, so that's fine. You can still do that to check your work, but we want to see the work done here. Okay, if I say complete the square, I want you to complete the square. Okay, so this one right here is going to be a little bit different. I cannot have any numbers other than 1 in front of the x squared. So here I'm going to divide every term by 2. So that's going to give me x squared plus 4x equals 6. Now I'm going to go on ahead and complete the square. Okay, and this I'm solving, so I don't need to worry about that 2. If I was putting it in vertex form, I would need to worry about it. Okay, but right now, because I'm solving, I don't have to. Okay, so now I'm going to go on ahead and I'm going to say x. Oh, I don't know what I'm doing, why I'm rewriting it. Oh yeah, I know why. So x squared plus 4x plus my blank equals 6 plus my blank. Okay, I'm going to take this and divide it by 2 and square it. So now I'm going to get x squared x plus 2 squared. So remember that number right there always goes here, equals 10. Square root both sides. So I get x. Sorry, long day. All right, I can't write. So x plus 2 equals plus or minus the square root of 10. I can't do anything with that 10. It breaks down to 2 times 5. Okay, so it's already in simplest form. So I'm going to subtract 2 from both sides. You guys need to get in the habit of putting that whole number in front of the radical. Okay. So pretend the radical is like a variable. Okay, the whole number always goes in front. So it's going to be x equals -2 plus or minus 10. And you can either write it as -2 plus square root of 10 and -2 minus square root of 10, or you can write it like this, -2 plus or minus the square root of 10. And then the last method we're going to talk about today is the quadratic formula. So you guys have seen this before. So memorize this. I am not giving you this on a test. You have to have this memorized. So negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, is another way to solve for x. Remember, the x values are called solutions, zeros, roots, okay, x-intercepts. Okay, that's what we're doing when we're solving for x. All right, so let's go ahead and do the quadratic formula a couple of times. So here, our a equals 1 because our coefficient right there is 1. Our b equals 10 and our c equals 2. Okay, so I'm just looking at those coefficients. I don't need any x's in here. Okay, so now I'm just going to write it out. So -10 plus or minus the square root of 10 squared minus 4 times 1 times 2 all over 2 times a. So -10 plus or minus, I'm going to work under the radical. 10 squared is 100 minus 4 times 2, which is 8, all over 2. -10 plus or minus the square root of 98, all over 2. All right, the square root of 98. Let's see, 98 divided by 2 is 49. Well, I know the square root of 49 is 7 times 7. Okay, so that's going to be -10 plus or minus 7 square roots of 2 all over 2. Now, yes, I could divide 10 by 2, but since I cannot divide 7 by 2, I am not going to be able to simplify this any further. Okay, in order to divide any of these numbers, I have to be able to divide all 3 of them by the same number. All right, let's take a look at the next problem. So it's 2x squared minus x plus 2 equals 0. Okay. If there was something other than 0 over here, you would want to move it and combine it with your c or your b or your a term. Okay, but there's not. So a equals 2, b equals -1, and c equals 2. So I'm going to say negative b, so +1 plus or minus the square root of -1 squared minus 4 times a times c all over 2 times a. So that's going to be 1 plus or minus the square root of 1. So -1 times -1 is 1. Minus 4 times 2 is 8 times 2 is 16 all over 4. So that's going to be 1 plus or minus the square root of -15 all over 4. And at this point in time, we haven't talked about imaginary numbers yet this year. If you remember your imaginary numbers, then you would need to do it this way. Otherwise, for right now, we're going to say that this is it and that there's no real solutions. Okay. And we'll talk about imaginary numbers in a day or two. Okay, and then your next one is going to be the same thing. So a equals 1, b equals 3, and c equals -7. So now I'm going to say -3 plus or minus the square root of 3 squared minus 4 times 1 times -7 all over 2 times 1. -3 plus or minus the square root of 9 minus 4 times 7 is 28, but that's a minus 4 times 1 times -7, so that's a -28. Be really careful with those signs. That's what students the most. Okay, so that actually gets added, so it's -3 plus or minus the square root of 28 plus 9, which is 37, all over 2, and 37, I cannot factor, so that's just going to stay like that. All righty. So the last thing that says B, but it's really part of A, is the discriminant. Okay, so this one and the next section are both A. So the discriminant, the part of the quadratic formula that is inside of the square root is called the discriminant. So if you'll notice, this B squared minus 4AC is what's in here. Okay, so that's going to tell us how many real solutions there are. So if I take the square root of a positive number like 16, okay, in other words, whatever's under that radical is a positive number or greater than 0, I'm going to get plus or minus some number. Okay, whether it's a 4 or whether it's plus or minus 2 square roots of 5, it doesn't matter. Okay, I get both a positive and a negative. So I get 2 reals or 2 real solutions. Okay, if this is 0, then the square root of 0 is really just 0. Okay, so I'm going to get 1 solution. So that's going to be 1 real solution. Okay, in other words, that's where my vertex is. Okay, it's on that number. Okay. And then B squared minus 4AC is less than 0. So this would be like if I was taking the square root of negative 15, like I did in this problem. There's no real solutions. I can't solve that without going into imaginary numbers. So I get no reals or no real solutions, 0 real solutions. Okay. So you don't have to actually do the entire quadratic formula to figure out how many solutions there are. You just have to do the discriminant, which once again is just the part that's under the radical. Okay, so for this one, the number of real solutions. Okay, the first thing I'm going to do here, I need to move everything to one side. So it's got to be x squared minus 6x plus 7 equals 0. Now I know my A is 1, my B is negative 6, and my C is 7. And now I can go on ahead and plug it in. So I'm going to do B squared, so negative 6 squared minus 4 times A times C. So remember, I'm just doing what's under the radical. The radical is not really part of the discriminant, but I'm just reminding you, you're doing what's under the radical. So that's going to be 36 minus 4 times 7, which is 28. And 36 minus 28 gives us 8. So the square root of 8. Okay. I don't have to break that down any further unless I tell you to actually tell me the discriminant. So in that case, that 8 would break down to 2 times 4, which would be 2 times 2. So that would be 2 square roots of 2. Okay? And it would be plus or minus. Okay? So remember, when you're looking at this formula here, that's why there's a plus or minus. Okay, all of these quadratic formulas, distance, and all of these formulas are pretty much all come from distance formulas or Pythagorean theorem. They all come from different formulas. Okay, so that's why they're rearranged. Okay, but this is a plus or minus. So there's 2 real solutions in this case. Okay, the next one, same thing. I have to move that 9 over. So I get x squared minus 6x plus 9 equals 0. Okay, so my A is 1, my B is negative 6, and my C is 9. Okay, so I'm going to do B squared, negative 6 squared, minus 4 times A times C. Negative 6 squared is 36 minus 36. So that's 0. So the square root of 0 is just 0. So that's 1 real solution. And then my last one here, you guys can probably guess what it is. So I'm going to add 11 to both sides. Okay, so x squared minus 6x plus 11. A is 1, B is negative 6, and C is 11. Okay, so I'm going to do my B squared minus 4 times A times C. So that's 36 minus 44. And 36 minus 44 is negative 8. So if I'm taking the square root of a negative 8, it's imaginary number. So there are no real solutions. There are 0 real solutions. Okay, so next section, we're going to be talking about imaginary numbers. And then we will be finding these solutions, sorry. We will be finding these solutions, but they're going to be imaginary.